Hello, space enthusiasts and curious minds. Today, we're diving into one of the most fascinating topics in astrobiology, the possibility of alien life on Jupiter's icy moon, Europa. Recent scientific advancements suggest that if there is life beyond Earth, Europa's hidden ocean might be where we find it. So strap in as we explore the depths of this icy world and the secrets it may hold beneath its frozen crust. New computer simulations reveal that low-temperature hydrothermal vents could persist on the shadowy ocean floors of moons like Jupiter's Europa for possibly billions of years. This breakthrough is driving astrobiologists to delve deeper into the possibility of these alien oceans being habitable. Hydrothermal vents are crucial as they provide both chemical energy and heat, and they are considered potential cradles for the origin of life on Earth. Planetary scientists speculate that similar vents, nestled in the oceanic depths beneath the icy shells of moons such as Jupiter's Europa and Ganymede and Saturn's Enceladus, could warm these alien oceans and possibly initiate the complex chemistry needed for life. However, most scientific modeling of these vents has traditionally centered on the high-temperature variety, specifically the volcanic black smokers that draw energy from Earth's heated core. But the frigid moons circling Jupiter and Saturn lack such thermal interiors, leading to uncertainties about whether these cooler vents can last long enough to sustain conditions conducive to life. Despite the common perception, the ocean floors of Earth are not dominated by superhot hydrothermal vents. In fact, a significantly larger amount of ocean water cycles through the Earth's lower temperature vents. Andrew Fisher from the University of California, Santa Cruz, UCSC, explains, "The volume of water circulating through these cooler vents equals the discharge of all Earth's rivers and streams combined and accounts for about a quarter of Earth's total heat loss." Remarkably, this process effectively recycles the entire ocean volume through the seafloor approximately every 500,000 years. Fisher led a UCSC research team that explored the potential existence of similar low-temperature vents on the icy moons of Europa and Enceladus. With limited data available on these extraterrestrial oceans, the team drew parallels with the circulation systems of the northwestern Pacific Ocean. They focused on the eastern flank of the Juan de Fuca Ridge, where cool seawater descends into the seabed through extinct volcanic features known as seamounts. This water travels roughly 30 miles, 50 kilometers, through subterranean paths, gradually heating up before it resurfaces through another seamount. In adapting their Earth-based circulation model to the ocean moons Europa and Enceladus, the research team fine-tuned variables such as gravity, temperature, bedrock composition, and the depth at which water circulates to align with the unique conditions of these distant worlds. Their findings were intriguing. Not only could moderately warm vents exist under a variety of conditions on these moons, but the low gravity also enabled warmer temperatures to emanate from the vents. Moreover, the inefficiency of heat extraction from the relatively cool cores of these moons, exacerbated by low gravity, suggested that such moderate to low-temperature vents could remain active for potentially billions of years. This study suggests that hydrothermal systems, which are not too hot for life, could be sustained on ocean worlds beyond Earth over timescales comparable to those needed for life to emerge on our planet, said Fisher, highlighting the potential for life-sustaining environments in the outer solar system. Europa, one of Jupiter's largest moons, has long fascinated scientists due to its icy exterior and the potential of a salty ocean lurking beneath. Recent missions by space agencies have provided compelling evidence that this ocean might be rich in minerals and warmed by hydrothermal vents, much like those in Earth's deep oceans that teem with life. This makes Europa a prime candidate in the search for extraterrestrial life. Hydrothermal vents on Earth are known for their rich ecosystems, where life thrives without sunlight, relying instead on chemosynthesis. Similarly, vents on Europa could provide the energy necessary to support life. These vents could produce a range of complex organic molecules, offering a potential habitat where life could develop independently from the surface conditions. The exploration of Europa's ocean is not without its challenges. The ice shell covering the ocean is estimated to be several kilometers thick, posing a significant obstacle for any mission aiming to explore these alien waters. However, advancements in ice-penetrating radar and submersible technology could soon open a window into this mysterious world. Discovering life on Europa would not only be a monumental scientific breakthrough, but also have profound philosophical implications. It would challenge our understanding of life's diversity and adaptability, posing new questions about life's existence in the universe. How does life begin? Are we truly alone? These are some of the questions that could be addressed with such a discovery. Several missions to explore Europa are already in the planning stages, with the potential to launch in the next decade. These missions aim to map the Moon's ice shell and investigate the composition of its subsurface ocean. The data collected could pave the way for future missions that might one day penetrate the ice and explore the ocean directly. Water is fundamental to life as we know it, and Europa's subsurface ocean is a tantalizing hint that it might not only harbor water, but also the conditions necessary for life. Scientists speculate that the interaction between the Moon's rocky core and the ocean above could create a chemical environment similar to that which gave rise to life on Earth. This segment delves into why water is essential for life and how Europa's unique conditions may be just right for biological processes to occur. The composition of Europa's ocean is a critical factor in assessing its habitability. Spectroscopic analysis from orbiters has detected hints of salts and organic compounds on Europa's icy surface, materials that may originate from the ocean below. Understanding these components is crucial because they can provide the building blocks for life and offer clues about the chemical processes occurring within the hidden ocean. Europa's orbit within Jupiter's powerful magnetic field exposes it to intense radiation, which presents both challenges and opportunities for life. This radiation could break down water and other molecules on the surface, creating potentially life-supporting chemicals that might find their way into the ocean below. This segment explores how radiation impacts Europa's potential for life and the protective role its icy shell may play. In our search for life, Europa is not alone. Other bodies in our solar system, such as Saturn's moon Enceladus and even Mars, have shown potential for harboring life. This segment compares the conditions on Europa with those on other celestial bodies, highlighting what makes Europa unique and what lessons we can learn from similar environments elsewhere in our solar system. Exploring an alien ocean under kilometers of ice requires cutting-edge technology. This segment covers the innovative tools and missions proposed to study Europa, including the ice-penetrating radar of the Europa Clipper mission and concepts for a lander that could drill through the ice or deploy a cryobot to melt through to the ocean. Landing on Europa's icy surface presents huge engineering challenges due to the harsh radiation environment and the smooth, icy terrain. Scientists and engineers are currently developing strategies to land safely on Europa, which could include using spiked landing gear or finding areas with thinner ice. This exploration discusses the ongoing developments and the critical factors that will influence the design of a Europa lander. A biosignature is any substance, such as elements, isotopes, molecules, that provide scientific evidence of past or present life. Pinpointing biosignatures on Europa would involve detecting specific molecules like lipids, proteins, or even genetic material. This segment explains how missions to Europa could search for these signs of life, using advanced spectrometers and other tools to analyze the Moon's surface and possibly its ocean. As we prepare to potentially discover extraterrestrial ecosystems, we must consider the ethical implications of interplanetary contamination. This segment discusses the protocols in place to prevent Earth microbes from contaminating Europa and vice versa, ensuring that we preserve the natural state of any ecosystems we might discover. Public interest in missions like Europa Clipper and the potential for discovering alien life plays a crucial role in the continuation of such ambitious projects. This segment explores how these missions capture the imagination of the public and the importance of maintaining public support for space exploration, which pushes the boundaries of our scientific and technological limits. The discovery of even microbial life on Europa would be a profound moment in human history, shifting our understanding of life in the universe and possibly affecting everything from philosophy to theology. This segment reflects on the broader implications of such a discovery, pondering how it would change our view of our place in the cosmos and what it might mean for the future of human exploration. Exploring Europa requires technologies that can operate under extreme conditions of cold, vacuum, and radiation. This segment delves into how current space technology is being adapted for missions like the Europa Clipper and potential future landers. Innovations in materials, science, robotics, and communications are all key to ensuring that spacecraft can survive and function effectively in the harsh environment of Jupiter's orbit. Space exploration is a global endeavor that benefits significantly from international cooperation. Collaborative missions to Europa could leverage diverse technological strengths and share the financial burden among nations. This segment discusses current and potential future partnerships between NASA, ESA, European Space Agency, and other space agencies in missions targeting Europa, emphasizing how these collaborations foster not only scientific advancement, but also diplomatic relations. To prepare for missions to Europa, scientists create analog environments on Earth that mimic the conditions on the Moon's surface and ocean. This segment explores the cutting-edge research facilities where these simulations occur, such as large ice tanks and pressurized aquatic habitats, and how they help scientists test equipment and theories before sending them into space. Artificial intelligence, AI, plays a crucial role in processing the vast amounts of data collected by space missions and in operating autonomous vehicles that may one day explore Europa's ocean. This segment covers how AI is used in mission planning, data analysis, and the potential future roles it could play in real-time decision-making on remote space missions. Looking beyond initial reconnaissance missions, the long-term vision for Europa includes potential habitation and resource utilization. This segment discusses the speculative future of human activity on Europa, from scientific bases similar to Antarctica to the utilization of local resources for long-duration space missions, providing a broader context for what initial explorations could lead to. Europa is not just an isolated moon, but a part of a complex Jovian system that influences and is influenced by Jupiter and its other moons. This segment examines how studying Europa helps scientists understand more about planetary systems as a whole, including the dynamics of celestial bodies, magnetic fields, and gravitational interactions within our solar system. Communicating across the vast distances between Jupiter and Earth presents significant challenges. This segment explains the technologies and methods used to maintain communication with spacecraft near Jupiter, such as the Deep Space Network, and how these systems are critical for the success of missions to Europa. As we venture into potentially life-bearing environments like Europa, it becomes crucial to consider how we can preserve these ecosystems for future generations. This segment discusses the principles of planetary protection that guide space agencies, and how these guidelines are essential for ethical exploration and scientific integrity. Discovering life on Europa would have profound psychological effects on society. This segment explores the potential human response to such a discovery, from increased interest in science and technology to philosophical and existential reevaluations of humanity's place in the universe. The documentation of Europa missions through films, books, and digital media plays a crucial role in educating and inspiring the public. This segment discusses the importance of capturing and sharing the journey of exploring Europa, ensuring that the story of our attempts to find life beyond Earth is preserved and appreciated by future generations. As we push further into the cosmos, the development of sustainable technologies becomes essential. This segment examines the innovations in propulsion, energy usage, and materials that are being designed to minimize the environmental impact of space missions. These technologies not only make missions to places like Europa more feasible, but also ensure that our exploration efforts are responsible and sustainable. The application of the scientific method in space exploration allows for systematic and reproducible discoveries. This segment discusses how hypotheses about Europa are formulated, tested, and refined based on data collected from missions. It highlights the importance of a methodical approach in unraveling the mysteries of the Moon and how each mission builds on the findings of the previous ones. The study of Europa is a melting pot of disciplines involving astrobiology, geology, chemistry, physics, and more. This segment explores how these diverse fields come together to provide a comprehensive understanding of Europa's potential for life and its environmental conditions. It showcases the collaborative efforts required to piece together the complex puzzle that Europa presents to scientists. Europa has captured the imagination of the public and has been a frequent subject of science fiction. This segment delves into how Europa's mysterious ice-covered ocean and the potential for alien life have influenced movies, literature, and art. It discusses the role of cultural products in shaping public perception and enthusiasm for space exploration. Inspiring the next generation of scientists, engineers, and explorers is crucial for the continuation of space exploration endeavors. This segment discusses educational initiatives and outreach programs that focus on missions like those to Europa, aiming to engage young minds in science and exploration. It covers how these programs are designed to spark curiosity and foster a long-term interest in the STEM fields. As international interest in celestial bodies like Europa grows, so do the legal and policy challenges. This segment examines the current space law regarding planetary protection, resource utilization, and international cooperation. It discusses how these laws are evolving in response to new technological capabilities and the increasing involvement of private companies in space exploration. In recent years, private companies have started to play a significant role in space exploration. This segment discusses how these companies could contribute to future Europa missions, whether through technological innovation, funding, or by launching their own missions. It evaluates the benefits and potential complications of public-private partnerships in space exploration. As missions become longer and more distant, like those planned for Europa, the mental health of astronauts becomes a critical concern. This segment discusses the challenges of long-duration space travel and the strategies in place to support the psychological well-being of crew members. It emphasizes the importance of mental health in the success of these missions. Funding is a pivotal factor in the continuation and expansion of space exploration projects. This segment discusses the trends in funding for space missions, including government budgets, international contributions, and private sector investment. It explores how these financial trends will influence future missions to Europa and beyond. Studying distant worlds like Europa not only helps us understand these celestial bodies, but also provides insights into our own planet. This segment reflects on what studying Europa's geology and potential biosphere can teach us about Earth's ecosystems, climate history, and the origins of life. It emphasizes the value of space exploration in broadening our understanding of Earth itself. Navigating the extreme distances and complex gravitational fields of the Jovian system presents unique challenges. This segment explores the latest advancements in space navigation technologies, including autonomous navigation systems and deep space network enhancements. These innovations are crucial for the precision needed to reach and orbit bodies like Europa, ensuring that spacecraft can effectively manage their trajectories and scientific objectives. Before any mission to Europa can be launched, countless simulations must be run to ensure its feasibility and safety. This segment delves into the sophisticated simulation software used by space agencies to model Europa's environment, spacecraft interactions, and possible scenarios that could occur during the mission. It highlights how these tools are invaluable in preparing for the unexpected and ensuring mission success. While solar power is a common energy source for missions closer to the sun, its efficiency decreases with distance. This segment discusses challenges and solutions for harnessing solar power in the outer solar system, especially for missions to Europa. Innovations in solar panel technology and potential alternative energy sources are explored, showcasing how missions are adapting to the low sunlight conditions far from the sun. As we plan for potential long-term missions that may include human exploration of Europa, understanding the effects of microgravity on human health is essential. This segment examines current research on bone density, muscle atrophy, and other health issues associated with microgravity. It discusses the countermeasures being developed to help astronauts maintain their health during long-duration missions. Communicating between Earth and a spacecraft near Europa involves transmitting data across hundreds of millions of miles. This segment covers the technologies and strategies used to enhance data transmission rates for deep space missions. It focuses on recent developments in laser communication and other high-bandwidth technologies that promise to revolutionize how we send and receive data from distant space missions. Exploration is deeply rooted in human culture and history, and the drive to explore Europa connects with these age-old narratives. This segment reflects on historical explorations on Earth and draws parallels with current efforts to explore outer space. It discusses how cultural values and historical context shape and are shaped by missions like those to Europa. Sustaining human life on long missions, potentially including stays on Europa, will require biotechnological solutions. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.